a little bit of a frame of reference for what we're talking about. So today, Wednesday, we're going to go through some computer science unplugged activities, and our hope or some of our goals are that you're going to be able to define computer science and some of the terms that go along with it. So starting to build your academic vocabulary in that area. Do a little work with the Maryland Computer Science Standards so that you understand a bit how to navigate through them. And then just find and use computer science unplugged resources. And today we'll be focusing on making connections to math and science standards, or to those kind of disciplinary content areas. Tomorrow, we are going to do Scratch programming using a program and platform from Google called CS First, which was designed for, I'd say, upper elementary grades. So that's going to give you an opportunity to have and gain experience with a programming language that's specifically designed for new to computer science learners. So for all of you who haven't taken a CS workshop before, this is the one of the best programming languages for you to start with. And that one is going to focus on some integrations with English language arts. So over the course of the 2 days, you'll be able to see connections to a couple of different content areas, and then continue developing our understanding of computer science vocabulary, but in particular, thinking about some programming and algorithm related terms that we'll use during that day. And then on Friday, we're going to talk through some issues related to equity in computer science education. Equity in education, is a huge topic overall, but there are some particular struggles and historical perspectives about what has happened in computer science that we will go through, and then identify some strategies for effective computer science teaching, some very concrete things that you can do in your classroom or that you can help student teachers learn to do in their classrooms, including facilitating well-structured collaboration for computer science. So any questions about that? Yes. Oh, thank you. Unplugged is without a computer. Okay. So we are going to start by doing a KWL chart using Jamboard. And I saw this, I always thought it was know, want, learn, like what do I know now? What do I want to learn? And then what have I learned after the activity? But I saw somebody use the W as a wonder. And I just thought that was a really nice way of putting, what am I curious about? What am I wondering? What's going on in my head? Not just what do I want to learn? Wonder is a nice connection there. So if you haven't used a Jamboard, I just want to walk you through a couple of features of it, and I will drop the link to it in the chat here shortly. But at the top of the screen, you're going to see this icon, and Jamboard has what are called like frames, or you could think of them as slides, like PowerPoint slides. But there are 3 frames in our Jamboard, one for what do you know about computer science, one for what do you wonder about it, and then later today we'll come back to the what did you learn about CS1. But this icon at the top and the arrows just allows you to navigate. So you would want to drop a post-it note on the what do you know about CS and what do you wonder about CS frames. And the way you get a post-it note is you'll see this toolbar on the left-hand side of your screen, and this one right below the arrow is the sticky note tool. So let me just open it up and get you the link that I can drop in the chat. People are just having their coffee. They are going to be talkative here in a little bit because we're gonna have them talking as part of an activity. So this is what you should see. First frame, what do you know? And then if I would click up here, this is the what do you wonder? And then you can click to go back. And then here's that sticky note tool where you just type in your notes and click on save, and it will show up on the screen. Now everybody's does show up in the same spot, so feel free to grab yours and move it around. All right. Any questions about using the Jamboard? Feel free to unmute yourself at any point too.
I love it. I love it. At first, it just popped right out there. I know nothing, everything to learn. Hopefully, lots to wonder about. Jen, I know for people on tablets, it's easier if you're not sharing your screen. It's hard to get to the
Sure, I can stop sharing for a bit here.
sharing it.
So I'm going to transition a bit into talking about some computer science terms and then into our first activity. So computer science, this definition comes from the K-12 computer science framework. And the reason I pull it from there is that the CSTA, the Computer Science Teacher Association standards, were built in conjunction with that framework. So they also use this. Many of the states, including Maryland, closely align with the CSTA standards. So this is a nice definition that you'll see commonly related to the student standards. So study of computers and their algorithmic processes, including their principles, their hardware and software designs, their implementation, and their impact on society. And part of the reason I love this definition is because of the last piece there, that impact on society. So computer science is not just about learning about, hardware and how to create software, how to collect and analyze data, but it's about learning what happens and how does that interact with society and change society, right? And how is it, how does that impact us in our daily lives? So we want to keep that in mind, that it's not just about the programming, it's so much broader than that. The other term that I want to share is the computational thinking definition that again comes from the K-12 CS framework. So the human ability to formulate problems so that their solutions can be represented as computational steps or algorithms to be executed by a computer. So that is the part where we as people have to start thinking like a computer, and how would a computer solve the problem? And how do we put the pieces of information together, whether it's an algorithm or data, so that the computer can solve the problem? And I think this is what Diane was referring to a little bit earlier. We can get part of the way there sometimes in many of our activities with, thinking about like an algorithm to make a peanut butter and jelly sandwich. But how do you get even further to really put that hat on and say, how does the computer interpret this, and where might it go wrong? Where would we need to debug and fix the errors? Because computers are very literal. They do what you tell them to do. And so usually it's a problem with our instructions in some way that we need to fix, all right? If you think about computer science and computational thinking is like a part of computer science, or sometimes people do it as like a Venn diagram where it overlaps, and there's some aspects of computational thinking that get applied to other areas as well. But they are linked together and they go hand in hand, all right? You might have also seen this. I know many education programs, many schools have a focus on ISTE and technology competencies. So ISTE does have computational thinking competencies for educators. So I just wanted to make that link there. Sometimes that's an in schools when you're talking to other teachers and trying to get them on board with what you're doing. So you may have seen it show up there already. And let me just double check the chat. Okay. So our first activity this morning is a Build a Duck challenge. So a little hard to do CS Unplugged completely when we're not all together face to face. So this one does use a computer, but you can do it without a computer. I had a workshop in the fall last year where we mailed folks little Ziploc baggies of pieces of ducks, Lego pieces that they could use to make ducks. And then we did the activity virtually, but you probably have things like this in your classroom that you could use to build a duck. It doesn't have to be with the computer, but we're going to demonstrate it with the computer. And it's some nice connections, I think, to math and geometry. So the directions here are going to be that we're going to go into breakout rooms, 2 people per room. And this is very much a challenge about like learning who your partner is and how to communicate with them and practicing some of those collaboration skills. So in your pairs, one person is going to be the navigator, or the person who gives the directions, and one person should be the driver, or the person who builds the duck with the online blocks or Legos, all right? And I'm going to model this, and if, I don't know if Diane is willing to be my partner for the first time around, We are going to turn our video cameras off. If you're going to do this in person, you could have the kids with their backs to each other so they can't see each other, so that they are giving directions blind and they can't, react to whether or not they're putting things in the right place or the wrong place. So the first part is the person who's a navigator is going to create their duck, so their model. And then once they've got it created, then they're going to give directions to the driver to create it without being able to see it. All right. And then we're going to turn our cameras on, share our screens, and see how closely our ducks match. And then you can, if you have time, you can switch roles and repeat the activity. All right. So let me model it, and then we'll see if anybody has questions. So I'm going to stop sharing, and I'm going to open up that first link that was on the slides. And today I probably have not dropped the link to the slides in the chat yet, have I? So let me just go back and make sure you have the slides link, and then you can get to all of the links that are in here too. Okay. So I'm opening the link that's this didax.com/apps pattern blocks, and I can drop that link in the chat as well, so you can kind of play around with it a bit while I'm building my duck. So I'll just be the driver the first time around, and Diane can be the navigator. And I have to say, I am not super creative about this, so I apologize for the appearance of my duck.
So I'll just hide the screen so other people can see how you do it, and that way I can't peek. So.
Oh, okay. I can. You want me to share my screen real quick so you can see the duck? Okay. So Diane is not peeking. She promises. There's my somewhat not so great, ugly looking duck. Actually, I think what I'm going to do is do that. That looks a little bit better. Okay. So that's what mine looks like. Diane, do you have your the didax.com pattern block screen up then? You do? Okay. So I will describe for you then what how to build the duck. So the first thing is to grab the red trapezoid, and I'm sorry, I should turn off my camera here because otherwise I'm going to start giving signals with my hands, and then that gives away some of the clues too. So stopping my video.
Maybe you could stop sharing, and then I could share and they could watch me struggle.
Oh, great idea. Okay.
It's more fun.
More fun that way. Okay. So red trapezoid, and put that kind of in the lower center of the screen. And then I can't look at you. That's the other problem. Okay. And then grab the yellow, let's see, 1, 2, 3, 4, 5, 6.
Hexagon.
Hexagon, grab the yellow hexagon and place it so that one of the sides aligns with the top of the trapezoid.
You're very precise.
I may have done this activity before. So grab another yellow hexagon, and now we're going to line up the upper left side of the hexagon that's already there with the new one. So it should kind of be like in the northwest corner of the hexagon. Those two sides should align. And then we'll take the blue parallelogram and we'll bring that to the southwest corner of that last hexagon that we just dropped on the screen, and kind of overlap it a little bit so that part of the parallelogram is on that yellow hexagon.
Am I done?
And then finally, we're going to take the white diamond and drag that over to the northeast corner of the first hexagon. And you want to click the rotate button a couple of times so that it's like turned sideways. and drag that so it like overlaps with that hexagon a bit.
I'm trying to decide which one I really think is the northeast corner. Okay.
All right, there we go. So there's Diane's duck, and you all saw my duck. Not too bad. Not exactly the same, but not too bad. Yay. All right. Do you have questions about trying that activity for yourself and with a partner? No? Okay. We're going to go into breakout rooms then with 2, maybe 3 people if we've got some odd numbers in the breakout rooms. And Diane, are you able to set those up, or do you want me to do that?
It's ready. It's ready to go. You just give the word. How long do you want them to be open?
It would be great if we give them about 15 minutes to do the activity. So you want to go through it, and then you can switch roles as well, and then try it in the reverse. Okay?
And make something that's not a duck the second time. It's got to be a mystery object. It's more fun.
That's true. That's a good variation on the activity. All right.
I'm always varying. It's hopeless. All right. So everybody's just going to sort of randomly fly into rooms of 2 or 3. So I know a couple people might have had to step away from their computer. So if you find yourself in a room with somebody who's not really there, just leave the room, come back to the main room, and we'll switch you to be with a group of people who really exist.
Okay. Good luck.
And up. And give me 1 sec, I just have to. Okay. Hey, Lori, are you on your phone? Hello, did you end up in an empty room?
Yes.
I am moving you. We have a couple rooms with just 2 people, so we will switch away here. Oh, are you guys both in empty rooms? I can put you in the same room together. Yes, there are a few people who you can tell aren't really here. A couple people are on their phones. Erin had to step away, but she will be back. So I'll just, if you go back into that room, I can send Julia in there. And then when Erin can come back, you'll be together. Julie, which room were you in originally?
I want to say the 3rd one.
Room 3. Okay. I'm going to put you in there with them. So that was room 7. There you go. And then I'm going to put you here, and then I'm going to move you back. So I'm actually going to move you twice so I can put you back in there. There. That should work. Did it pop up on your screen to invite you to the room?
No.
Oh, silly thing. It should have. Well, go ahead and make something. I'll try to make it. Build something, anything.
Okay, I'll make something.
There'll be other people who are going to wander in here. Yeah. It's a game I like playing. Hey, Lori, are you not able to do this because you're on your phone?
Yeah, it's real sketchy. So I'm gonna just kind of hang with you for a minute, if that's okay.
Yeah, no, that's great. You can always come hang back here. Was Jerry in the room with you, or was Jerry not participating?
He wasn't. Yeah.
Yeah, I thought
he didn't respond. So yeah.
Okay.
I love this activity though. I think I'm going to use it with the students in the fall.
I like it with the actual Lego blocks. There's Lego blocks online where they're three-dimensional looking.
Uh-huh.
And so it sort of adds
Oh.
another element of three-dimensionalness to it. I was just looking for the link to that. I'll add it to the slide if I can find it. It used to be free.
Do I need to join?
Going to be, and how are we going to name those so that people can find the information they want? Another person might be really focused on the user interface and making that work well, where to put information on the page, what colors and fonts to use, so it's clear how to read and use the website. Another person might be focused on the functionality, like creating a checkout, shopping carts, creating a search function, creating filtering, that kind of thing. And then another person might be the testing, making sure it all works. So we've decomposed it into these separate areas that each person is responsible for, but they all have to work together in order for that website to work in the end. So that's one example of decomposition. This next idea around algorithms, we talked about that a bit, is the step-by-step directions that a computer can follow, not just a person, but a computer can follow in order to solve a problem. So we do some practice things that get us closer to that. So the activity we just did with the duck, the peanut butter and jelly sandwich, tying the shoes, directions, those all get us closer to that. The trick is like, how do we get really precise about our directions so that a computer can read them and solve them? And what you see over on the far right there, this is blocks of code in a computer program. And so that's like the end product. When we take an algorithm and we convert it to a program, we need it to be like that level of precision, all right? In the middle is an example of a nice activity that allows students to make connections to their home environment and do an activity with their family. So creating directions to a room in your home or a place that you visit, and then test it out with a family member, maybe have somebody else create directions, and then have this like critical thinking around whose directions worked better, whose directions were more efficient. So those are some really good conversations around writing algorithms, that there's, not just one way to solve it. What are some qualities of our algorithms we might want to look for? So pattern recognition is another one. This idea that when we're writing code or we're working with data, we want to be able to recognize patterns and then generalize them so that we can create solutions that apply to other similar problems. Because computer science, you see very similar problems show up over and over again, or portions, that decomposition, portions of problems show up, like sorting a list of names. That's a problem that shows up over and over. So how do you come up with an algorithm for that and recognize that as a pattern so you can reuse that algorithm in different programs? So you can work with students on just pattern recognition in general. This is a nautical flags chart, and you can talk about things like colors and shapes and different designs that show up on it. But you can also talk about it in relation to patterns in code. So this is an activity with a deck of cards. And if you imagine that the deck of cards is sorted and you want to find a particular card within the deck, since you know that it's sorted, you might use a strategy where you, like very similar to a dictionary, where you go to the middle, you'll look at the middle value, and then you know that you either need to go to the top half of the deck or the bottom half of the deck to find your card. And then if you go to the top half, you can use that same strategy. You go to the middle, and then you determine whether if that's not the card, you go to the top half or the bottom half. So being able to recognize that pattern where you're looking at the middle card and then evaluating which side of the deck you want to use, that's a pattern. And instead of writing all those steps out separately, we can use something called a loop or repetition. We can repeat those steps. So if we can recognize a pattern, then we can use the repeat to ask it to do those steps over and over for us again. Okay. And finally, abstraction. Abstraction is the idea that we're just simplifying and hiding the details so that we can focus on the most important part of the problem to solve. You probably use your phones and your computers to look at pictures and images all the time, but the details of how that is stored in the computer has been abstracted away for you. Zeros and ones, that's the binary code for how data is stored in a computer. So that is all hidden from you in terms of the details, and you don't think about that because the computer and the software provides an interface to make it really easy for you to use that. Concretely, in a computer program, we can do something called writing a procedure, and that just means that we give a name to a block of code. Now, this is a really simple procedure. It just has one command to it, but it has a name called say hello procedure. And if I want to use that somewhere else, then all I have to do is say call say hello procedure. I don't need to know about the code that's inside of it. So I've abstracted away those details. I've simplified it so that I don't have to know how it works. I just know that it's going to say hello. All right. So those decomposition, algorithms, pattern recognition, abstraction, those are 4 of some of the computational thinking computer science concepts. We can do integration across all kinds of different areas. We're going to be focusing a little bit more on math today, but just to really point that out, you can do it with art, you can do it with social studies, you can do it with science, reading, all kinds of different things. All right. And then the last part, practices. So I've just grabbed some of the practices that come from some of the different resources out there. So Scratch identifies some practices like experimenting and iterating, testing and debugging, reusing, remixing, abstracting. So something that is called a concept in one place is they call a practice here. Barefoot Computing is a resource from the United Kingdom, and they call their computational thinking practices tinkering, which is kind of this experimenting and iterating, playing around with and trying things over and over, being creative with what you're doing, debugging, that's that testing and fixing problems, persevering. I love that they call this one out because I think one of the things that happens, somebody mentioned this earlier with the duck, it's like, you know what, I didn't get it right the first time, but I know I can do better. And that perseverance, like continuing to try and improve each time and knowing that, it's probably not going to work quite right the first time and that you're going to have to keep going. And then collaborating. All right. So I put these down here so you could kind of see some of those words as we talk about it, but maybe just drop in the chat. How did you use some of those computer science and computational thinking concepts and our practices during that Build a Duck challenge? I'm going to catch up on the chat here. Oh, I see somebody mentioned a word bank. Awesome. Debugging, restating how to your directions when you thought maybe it wasn't going the way you wanted to. Definitely some creativity in how you designed your personal duck and collaboration. Love it. Creating and tinkering, adjusting, collaborating when you weren't sure of the directions, and even just communicating with each other. Great. Evaluation. Evaluation is that idea. Is it working the way I want it to work? Do I need to fix it? Wonderful. So many great connections you all are making in the chat. Now, I'll ask the question, did you use those words when you were building your duck and talking about your duck? Yeah, maybe not so much, right? So I think one of the keys, yes, to making it a computer science lesson and computer science instruction would be able to talk with students about some of these aspects. So I did mention at the beginning a little bit about collaborating and creating. I didn't mention some of the other pieces. When we recapped, we came back to the idea of algorithms and precise instructions and that sort of piece, right? But that I think is one of those keys that if you want it to be more than just an icebreaker activity or an activity that is connected to some math concepts, we also need to have some direct and explicit instruction around those computer science concepts as well. So being able to talk to students about their directions being precise as related to an algorithm and a computer being able to execute or build it, the tinkering and creating aspects of it. Right. Okay, I think before we get into this, is it time for a break first? Yeah, because we've been here about an hour and a half. Let's go ahead and take a 15-minute break. And so we'll come back at 10 after the hour. You can do some stretches. This is always what I like to get my shoulders stretched. Yes. Touch my toes a little bit, stand up, move around. But we will see you back here in about 15 minutes and we'll do one more activity.
Perfect timing. I was just out of tea.
Okay, me too. I'm going to go grab some tea. Do we want to pause the recording?
Yep. Oh, I had already paused it. Hot.